So graphing polynomials. It's not too difficult. It is taking a lot of steps though, which can be a little confusing. So we're going to break it down. Our first step is going to be to find the leading term. Step 1. Step 2, find our zeros. Step 3, symmetry. And then I think that's it. All these steps, they have more to them. So the first one, and actually I wanted to say before we move on to our first example, there are some tips. So I'm going to put a little star, and it's for the leading coefficient test. So this test basically tells you the end behaviors of your graph. It's going to tell you how the graph starts, if it's going up, if it's going down, and how it ends. Again, if it's going up or going down. And in which, if it's to the left or to the right. So the first case is if your n, so let's say this is my coefficient, my term is going to be, let's just say 5, or I'll keep it general. A, X, N, right? That way I can just use general terms. So my N is my exponent, my X is the variable, and A is the coefficient. So if N is odd and the leading coefficient is positive, I'm going to call it the LC, is positive. That means that my graph will fall on the left or to the left, fall to left, and rise to right. So that just means that the graph, when it's graphed, and I'll erase this in a second, it's going to just look like this, right? It's going to be going down on the left side, up on the right. So that's what this leading coefficient, there's 4 cases, I believe. And those 4 are basically going to tell you, well, these are your rules. And that's why the step 1 is kind of really important, because it gives us like a general basis, right? If I have the graph and I'm starting it and I know it's going to go up and then down, right? I can at least already kind of get started. Oh, there's the first parts of my graph, and then I can fill in the rest. So it is very convenient to know that. So the second case is if n is odd. So once again, if my exponent is odd, but in this case, my leading coefficient is negative, then my graph is actually going to rise on the left and fall on the right. Graph rises to the left and falls to the right. So again, it's going to look something like that. These aren't perfect, but that's just the general shape of them. The general end behavior really is what it's actually technically called, the end behavior of the graph. So the third one is if the exponent is even and the leading coefficient is positive. In this case, both ends will rise. Both left and right rise. So it would be, I'm not even going to draw the coordinate anymore, but it would look something like that, more like a W. And then the last case is if let me see if I fit it in. If the exponent is even and the leading coefficient is negative, both fall. So it would look more like an M. So now we're actually going to go ahead and work on an example, or actually two examples, just so you can see the steps. So this is our first function, right? We have f of x is equal to x to the fourth minus 2x3 minus 3x squared. So our first step is our leading term. Our leading term is obviously the one that's right in the front. So it's our x to the fourth. Now in this case, my leading coefficient is 1. So I can go ahead and figure out, well, let me see. If my, and you know, you go back and you see, well, my n, or my exponent, is positive, or it's an even number actually, I should say. So it is even, and the leading coefficient is 1, which is a positive. So that means I already know that my graph most likely is going to go up and up, right? It's going to rise to the left and rise to the right. So now my step 2 is finding the zeros. So my zeros are really my intercepts. So when it comes to finding my x-intercepts, right, we're going to do that first. I'm just going to call them x-int. I need to find the zeros. So I need to do more factoring. In this case, I can factor out an x squared. Right, that leaves me with x squared minus 2x minus 3. I can go ahead and factor this out some more. So it's going to be a minus. Negative and a negative is a positive. And that's going to be, I need a negative answer. So my 3 is going to be here. My 1 is going to be there, right? Negative 3 plus 1 is going to give me negative 2. So I did the shortcut on this one. So that gives me my factored form, right? Those are my 3 zeros or x-intercepts. Now to find those points on the graph, I need to actually do x squared equals 0, x minus 3 equals 0, and x plus 1 equals 0. So I need to square the square root. That eliminates my exponent, and that gives me x equals 0. I'm going to add 3, subtract 1. So those are my zeros. Okay, so we need to figure out if they're going to either touch the graph or cross over. Okay, now to figure that out, we have to use what's called the multiplicity. And basically the multiplicity is looking at the degree of your factors, right? So we have 1 and 1. If the multiplicity is even, it will bounce. So it'll bounce off the axis, and if it is odd, it will cross. So in this case, I have x equals 0, which is going to be in twice, right? Because it is to the second. So that means it is going to bounce. So at x equals 0, it's going to bounce. At x equals 3, so there's only one of these, so it's going to cross. And the same thing for that negative 1 is going to cross. Okay, so now we've already figured out 3 points. We know the end behavior of the graph, and we want to keep going so that we can find more information. And we also have to remember that these points when we do our x-intercept, these are the points on the graph when the y is equal to 0. So this is -1, 3, 0, and 0, 0. And I actually have 2 of these because of that multiplicity. The multiplicity is telling me, well, this value is going to be on your graph twice. Okay. So that's my x-intercept. Now I want to do my y-intercept. And I'm going to need to do some erasing, and I'll move this over so that it's up here. And we're going to do our y-intercept. So my y-intercept is when my graph is set equal, well, my x's are set equal to 0. So in this case, right, and f of x is just y, really. So y equals 0 to the 4th minus 2 times 0 cubed minus 3 times 0 squared. So when I go ahead and take this, that's going to be 0, that's going to be 0, that's going to be 0, and 0 minus 0 minus 0 is just 0. So my y-intercept is at 0, 0. Okay. Now, the next thing we want to do is symmetry. So symmetry, it can be a little bit confusing. I still get confused every once in a while. For my symmetry, I'm going to separate this. For my symmetry, what you have to do, so for symmetry, is we're looking for the y-axis. My goal is to see whether or not if I plug in negative x to every place that I have a x value, if it equals the same as the original, then they are symmetric. They have symmetry. So for this case, I'm going to take my f of x, and I'm going to plug in negative x to the 4th minus 2 negative x cubed minus 3 negative x squared. So remember, I need this equation, this should have to be negative, to match my original. So if I take x to the 4th, since it's an even number, I know it's going to end up staying as a positive. So I know it's going to stay x 4th. So far, my first term matches. Now the second one, a negative x to the 3rd. So since it is to an odd number, my answer is actually going to end up being a negative, which means it would be negative x times 2, which is going to give me actually a positive 2x cubed. Now already that should be a red flag. My original is negative 2x. It's not going to match, even though this last term does end up being true. So because of this one here, there is no symmetry. No symmetry. And that's with the y. So if I want to look at the x origin, or actually the symmetry about the origin, I'm going to do the same thing, and then I'm actually going to go backwards and multiply my original by make it entirely negative. So I already know that when I plug in that f of negative x, it's going to give me a x to the 4th plus 2x cubed minus 3x squared. So basically, if this answer equals what I'm about to do, they'll have symmetry on the origin. So what I'm actually doing is the outside. So negative x to the 4th minus 2x cubed minus 3x squared. So when I do this, that gives me negative x to the 4th plus 2x cubed plus 3x squared, which I can see these two are not the same, so no symmetry. So there's actually no symmetry in this graph, so it's not going to look very nice and even, okay? It's going to look a little bit chaotic, but, you know, we have at least a lot of points, so we can try and figure this out. So I have right here a graph And I'm going to plot all of my x-intercepts. So I'm going to have a point at 0, 0. Actually, let me change the color so you can see it a little better. 0, 0. Then I have 3, 0. And negative 1, 0. Now, this doesn't have to be perfect, right? I'm not using a graphing calculator. This is just using the rules that I know. So I know it's going to bounce. I know it's also going to go up on both sides, right? It's going to rise and go up. It's going to be in kind of like a W kind of shape. So I know I'm going to bounce at 0, 0, and I'm going to cross over at negative 1 and 3. So if I'm going up, and like I said, it does not have to be perfect. I'm going to actually start a little closer. I'm going to cross. I'm going to bounce. And I'm going to go right back. Right? Now, if you wanted, you can, of course, search for various points. I could look for points in between. For example, I could have, well, let me see if at 1. So when x equals 1. Well, I do the original equation, which is 1 to the 4th minus 2, 1 cubed minus 3x, or 1 squared. Right, and I can do that. That's going to be 1 minus 2 minus 3. So that gives me negative 4. Right? You can go ahead and do that. It'll give you a much more accurate graph, but you don't have to. You're showing, look, this is kind of what the graph is going to look like based on this information. If you're looking for a more accurate graph, I would definitely recommend filling out points between. You only have half a point between negative 1 and 0, meaning you would want to do 1/2, but that seems a little bit difficult because you are going to have to deal with fractions in that case and decimals, and it won't be very accurate because most of the time graphs are not done with, they're usually done with whole numbers. So I would recommend, the best part would have been to do, at 1, at 2, and just to see where it goes, okay? Without doing that, this would be unacceptable graph, right? This is, well, I showed this work, this is what I have, this is what I think it'll look like. Okay? We're going to do one more. I know it does take a little bit longer, but they do, it is helpful to cover these bases. So my leading term is negative 2x cubed. So now in this case, my leading exponent is negative, or is odd, and my leading coefficient is negative. Meaning, and if I go all the way back, so odd and negative, so it's going to rise to the left and fall to the right. So it is going to rise to the left and fall to the right. Something like that, right? We don't know because we haven't done the multiplicity, so we don't exactly know what it's going to look like, but we know at least the end behaviors. So now we can go ahead and get started on our x-intercepts. So remember, that's just factoring. So I have negative 2x cubed plus 2x. I can actually factor out I'm going to factor out a negative 2x. That's going to make things a little easier. That leaves me with x squared minus 1. Remember, I have to multiply. I have to change the sign so it matches. If I distribute that negative 2, how do I get back to that positive 2? So now I can do negative 2x equals 0. And my x squared minus 1 is actually going to factor out into that x minus 1, x plus 1. So those are also going to be x minus 1 equals 0, x plus 1 equals 0. I divide this by negative 2, x equals 0, so that point is at 0, 0. I add 1, subtract 1. So those are the points 1, 0 and negative 1, 0. Okay, so those are the first things. Now we're going to look at the multiplicities. So in this first one, I only have one of these, so it's going to cross. And I think all of these are actually going to cross, right? Yeah, they only go, you only have those answers once. So cross and cross. Okay, so I know on every single point in this graph, when I hit my x-intercepts, it crosses over. So now I'm going to go ahead and do my y. And I think I have enough space. I'm going to use a different color for the y-intercept. Right, that's setting 0 or y equal to negative 2, 0 cubed plus 2 times 0, which is just going to be 0, 0. So just like the last one, the y-intercept is still 0, 0. Now I'm going to look for symmetry. I'm going to change color again. This one should be a little bit neater. So symmetry, I'm looking for the y-axis first. So that means I'm going to change everything. Negative 2, negative x cubed plus 2 times negative x. Well, I can already tell, right? I don't even need to look at this one. I know that this is going to end up being a negative 2x, which is not what I have, right? So this would actually also be a positive. So this would be an entirely opposite answer. So, I still need to figure this out. So when I do the origin next, right? Because this would be x squared. That's going to be a positive x times 1 extra x is a negative. Negative and a negative is positive. Now, so I know there's no symmetry about the y-axis. And then I know that I'm going to do the origin. So remember, my origin, I need to have it match up with this one. So it's going to be negative 2x cubed plus 2x. And if I distribute this negative, that's going to be a positive 2x cubed minus 2x. So we can actually see these are equal to each other. So I do have symmetry about the origin. So that means that they're going to be relatively equal to both sides. But we'll see about when we graph that. That's something more you'd notice on the graph itself. So we now have our points. I'm going to write them out here. 0, 0, 1, 0, negative 1, 0, and at all three of those points it's going to cross. So I have my 0, 0. Let me do the pink again. 0, 0, 1, 0, and negative 1, 0. Okay, so I know it's going to be pretty even, so I'm going to do my best. Right, it's going to cross one more time, cross again. I messed up right there at the end. So cross, 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 and it's going to keep going. And again, that's basically without doing additional points, right? Because these are only one in between, meaning the points I'd have to do are halves. And I don't really want to have to do fractions or decimals in this case. So without doing that, this is the way your graph should look, right? You have the two different end behaviors that you figured out from the leading coefficient test. We have our intercepts, we have our symmetry, and that's it when it comes to graphing rational expressions and polynomials.